Hey guys, I am live. Let's go through. It's gonna be a fun 3 days, okay? We're going to have a nice 3 days of questions preparing for the test. So it's gonna be tonight and tomorrow, sunset and in the evening, or tomorrow in the evening, and Monday night as well. So I'm going to be just going through questions, quickly making sure you are good at everything in Emath 301. Everybody, make sure you have subscribed. Make sure you have subscribed before we start, and then now we are starting. Okay, so what I'm going to be doing is going through questions. Somebody told me that you are recommended to go through test one, assignment one, test two, assignment two, and then obviously we do the theorems, which come after that. Okay, we'll do the theorems and vectors. So I'm just gonna quickly go through test one and assignment one, and then test two and assignment two, and then the theorems as well. Those are the things that we're going to be doing as questions, trying to see how it goes. Okay, so first of all, we're going to go through. This is how it is. Let me just show you how your Emath is like Emath 301. Give me a sec. Let's say. All right, so here is going to be what Emath 301 is going to be like. Can you, if you can't hear me, then say it in the chat so I can see that. If I'm not loud enough, say it in the chat, and then I'm going to know that I'm not loud enough, and I'll adjust my volume to make sure all of you can hear me and all of you can hear me nicely. Or if there's background noise or anything, be sure to communicate with me in the chat, then I'll be able to see it. All right, so here it's going to be, let's quickly go through the stuff, and I want you to master it and just be good. This is going to be your Emath 301, which is differential equations, the differential calculus. So basically, how it goes is, we can say it is divided into three, okay? Part one is the things that came in test one and assignment one. Okay, things that came in test one and assignment one. This is part one. Then there is going to be part two, which is the things that were in test two and assignment two. Okay, we should know them as well. Things that were in test two and assignment two. Then there is going to be last and final part, which is going to be part three. Part three, these are just, okay, I can just say in summary, these are just the theorems and vectors. And it's over. So these three sections talk about the whole of your, if you know these three, then you're good. If you know these three, you're good. And this is the whole of Emath 301. So if we put it, part one, what does it have? We can say part one is going to have here, I can say 4 methods in part one for you to know the things that for you to say, oh, I'm done with the very first part of my Emath 301 and I'm good, and I know that every question that is going to come from that section, I'm going to answer it, and you're going to get 100. What you must be able to do is what? So let's go through it. Let me increase my volume a little bit. It looks like my volume is a little bit too low. So what happens in this part one is, here's the thing. You have 4 methods for you to know and for us to say, wow, you're good. And that is going to be, we'll be having differential equations, and you're going to be solving them. Number one, you're going to be solving them by separation of variables. So you should be able to do the method code, which is common sense. This one I don't like doing it first because it's a little bit of common sense. So there's going to be separation of variables. This is going to be what? The very first thing. Then the second method, which you must be good at, is going to be how to solve differential equations using the integral factor. And then you can do the other 2 methods, which is going to be method number 3 and method number 4. Method number 3 and method number 4, we can just say In method number 3, you're going to be solving, and I can do it like this. You're going to be solving homogeneous second order. Then, in here, you're going to be solving non-homogeneous. And we can say in here, when you're solving these non-homogeneous, you're going to use the idea to say that y is equal to be the complementary function plus the particular integral. This one. So that is for method number 4. So in particular integral, you're going to use the table to solve. So let's talk about it. If you know these methods, you're good. And you should be knowing how to do them, how to solve them. You should know it. So here are the 4 methods that if you're good, and you should know what happens in each. If you're asked even in your sleep, you must be able to know, oh, for this one, simply what happens is 1, 2, 3, 4, 5. Is my volume high enough? Is my volume high enough? I'm kind of worried. Okay, I think it's high enough. I think it's high enough. Okay. So basically, here's the thing. So the 4 methods, right? And we can waste time talking about this. You should know, okay, that these 2 are for first order differential equations. In other words, these 2 methods, you're going to use them only when you have only dy dx. Differential equations are just equations that have the derivative in them. So and our job is to move back, okay? It's like we'll be actually integrating, but then why they are called differential equations is you don't only integrate. For some, you don't even integrate. You'll be trying to find constants, okay? But you're going back from dy dx, going back to y, and there are some constants that you're trying to find. You'll be trying to create the original equation and also the constants that were there. That's what we'll be saying differential equations are. Now here for homogeneous second order, for these 2 and non-homogeneous, these are second order differential equations. And when they say homogeneous, it means it's going to be equal to 0. So you're going to get a second order that is equal to 0, and that is going to be it. Anyway, this is going to be what comes in. These are going to be the 4 methods that come in test 1. Maybe let's concentrate on them. And when we're done, we're going to talk about what the part 2, and I'll be moving with you. This is just what we're doing. This is how we're going to do our Emath. So now I'm going to move. After this, I'll move with you to part 2, where we talk about the power series. Then we'll talk about how you're going to have the methods to solve partial differential equations, where a lot of people have problems, but it's not even hard. We'll talk about it. Let's start with mastering these 4 methods and answering the questions. We want to quickly answer the questions that come. So I'm going to teach you by doing questions. I'm going to be explaining what I'm doing, but using the questions that are inside your slides. So basically, but let me just tell you what you must know from these. You only have 4 methods here, and we'll be saying you are done with the very first part of differential equations. From here onwards, you are not going to find differential equations. You'll be finding now partial differential equations. So we can say ordinary differential equations finish here. If you know these 4 things, we say ordinary differential equations are done. From here now, you'll be getting partial differential equations. But as for ordinary, we are done. So you need to know these 4. From here, don't worry about it. You are no longer going to be meeting the same types of questions. So these methods, there's a type of question you're going to be getting from these methods, these differential equation methods. From here, you are now going to be doing partial differential equations. They're completely different from this. But then you use some things that you're going to learn here as well. So that is why it's important to start with part 1. Okay, so we'll see about partial differential equations. But let's quickly do, these are ordinary differential equations. Let's see the 4 types and let's master them and let's solve the questions. Like I said, we are going to be solving questions. So I want us to move step by step in a way that you're never going to forget. Now, let's start. So what did we say for solving differential equations? You only have 4 methods. So if you look at the questions you got in here, let's look at the questions that we have where we're solving. I don't want the questions to say define order and all that. We'll talk about it. Define linearity. We don't want that. We want these ones that say find the solution. Find the solution, okay? Given that x is whatever, solve. And they give you a lot of marks. Then here you have no define. No, we don't want definitions for now. We don't want definitions. Here, solve the following ordinary differential equation. Yes, it is an ordinary differential equation. Then define. No, we don't want define at this particular moment. Then the next one says find the particular solution, whatever differential equations. Yes. So now let's start. So here are the 4 types. You can actually see 4 questions from the 4 types. This is type number 1. This is going to be type number 2, and you're given 19 marks in the assignment. This is type number 3. Then here is type number 4. Here we have these are the 4 types of differential equations. We have of ordinary differential equations. And when we're done, you'll be like, yes, I'm done. Good. And the first one, they say is going to use the method called separation of variables. Now, what you know is that the method called where we use the method of separation of variables, and also where we're going to be using the integral factor, which is going to be here. I'm going to show you what in here what happens. These two are going to be for first order differential equations. So these two methods work for first order. In other words, you only have dy dx. First, the order tells you the highest derivative you have. If we say a differential equation is second order, it simply means there is the second derivative there. So if it's second order, we expect to see a d2y dx squared as the highest derivative, right? And that is, of course, you end at second order. We don't go above that right now. So here we'll be saying, okay, so for these first two is for first order, then these last two for second order. So these last two second order. Okay, but one is linear, the other one is linear, the other one is like just homogeneous, the other one is non-homogeneous. So let's just talk about it. This one you can see it is equal to 0, so it is the homogeneous type. Okay, it is the homogeneous type. Then here you can see it is equal to something which is not 0. So this one we say it is the non-homogeneous second order. Why is it second order? Because we can all see that we have a second derivative in both situations. So these are second order differential equations. Let's go ahead and let's solve all 4. Nice and simple, quick, fast. So I would love to start with the last two, then go to the and do the first two. Okay, first two, I'll tell you what integral factor is, and how you quickly should be able to identify the parts that you need to identify. That's very nice and fun. But let's start with the last two. So class, remember I told you that you are not going to meet this type of question in the next sections. You won't. So it's finishing now. So you must know what you do for this situation, then we move on to something else. If you get a question to do with having this situation, then you can't start thinking about it's exactly what we're learning now. What you're learning now is what you must apply in whatever situation that you're going to get, like this. So let's start with this one. You are in an exam, and then you're going to get a question which says, please solve this question. Then they say y prime prime plus 4y prime plus 5y is equal to 0. So you have y prime prime plus 4y prime plus 5, is it y? Whatever, let's see. Plus 5y is equal to 0. So all I need you to do is look at this differential equation you're solving. And you are trying to identify which type is this. You see the second derivative. And you see it equal to 0. So that's big. When you see the second derivative, you know, oh, this is going to be second order. And you see it equal to 0, you know, oh, this is going to be homogeneous. Okay? So what you must know is that once you see yourself having a second order homogeneous differential equation, you have to convert whatever you have been given to what we call D operator form. So let's talk about the steps here. I can tell you the steps right now and tell you that the part which you have to remember going into this, because the other parts anyone can do. But I'm going to tell you the steps and something which everybody in here must remember for you to solve this type of differential equation, because it is resting on one thing, which is going to be the types of solutions. That's what it's resting on. Okay. That is what this, and this part you must master it because it's going to be required in the next section. So you have to be able to be good at this part. So let's start by saying, we'll talk about the 3 types of solutions. First, I want you to talk about the steps. Okay, this is second order and it's homogeneous. Second order because you see the second derivative. Homogeneous because you see it say equal to 0. So what are going to be the steps? Step number 1. Okay, I'll show you one which is non-homogeneous. Sometimes it may be equal to something with a y. If it's just equal to something with a y, take all those things with y to one side and you're going to have it being equal to 0. It will be homogeneous. Now in steps, what do you do in step number 1? Step number 1, you're going to convert. This is so easy. You convert to D operator form. Okay, you're going to just convert to D operator form. Then from there you're just going to make an auxiliary equation. We say you then make an auxiliary equation. Okay, then you're just going to solve. 3, solve. Then 4, okay, solve. And in solving I want you to know that you use the quadratic formula. Use the quadratic formula. Okay, and I don't really want to give you a step because I'm afraid you guys are going to start trying to cram. This is coming from my head because it's so easy. You can all know that. You just convert it to the operator, you make an auxiliary equation, then you solve it. You solve that auxiliary equation because it will be in terms of m. Once you solve that auxiliary equation, then you're going to choose y. Choose y from the 3 types of solutions. And then once you choose y, we can now say 5, find constants. Find constants using conditions. Then you're done. You just find the constants using the conditions. This is common sense. Everybody should know that as an engineer, you have a personal pride. You don't lose marks to this type of stuff. You're not going to lose marks. Now, there are things that I want you to know. Let's talk about the things that you're going to need to actually know for you to solve this, because the steps anyone can be. What I want you to know here is now. Let's put it right now. The 3 types of solutions. Please don't cram this, you'll be cooked. You should know the 3 types of solutions of these homogeneous equations. The 3 types of solutions will be, number 1, if, remember that the solutions depend on m. They depend on the answers you get in your auxiliary equation. You're going to solve your auxiliary equation. The answer you get, the values for m you get, will now help you to choose a solution. So if m1 and m2 are distinct and real. Distinct means what? They are different. Distinct means they are different. And if they are real numbers. We'll talk about complex numbers. Then what you should have is you should then come and say y is going to be, you have to choose, you have to remember this, ae to the m1x plus be to the m2x. That'll be your m1 and m2. You're done. Now let's talk about the second situation. So it is ae to the m1x, ae to the b2, the second solution, be to the second solution of x. Then now we're going to say if m1 and m2 are the same value, are real, but both the same value. If they are real but they are both the same value, then the solution you're just going to choose, you're just going to say that means your y is going to be, this is how you choose your y, it's just going to be ax plus b, then e to the mx. Done. Then here's the third and final thing. If m1 and m2 are distinct and complex, this is the last type of situation, then that means if they are distinct, it means different, and they are complex numbers, then you're just going to have y is going to be equal to, sorry for that, you're just, okay, so sorry. You'll be having your m, let's say m1 is going to be alpha plus beta I. Then obviously that means the second solution you'd get will be alpha minus, because this is how the solutions come in complex. They just differ on the sign here. So now what you'd be just saying is, you just have it saying, that means your y is equal to e to the alpha x. Then you just say, you now create your two constants, okay? I can put b or I can put a, doesn't even matter. It's just going to be a cos beta plus b sine beta. And beta, what is it? It is going to be the imaginary part. The real part, which is a number, remember that these are going to be numbers in the situation you are going to get. Remember that. So the imaginary will just come inside the bracket to be b sine beta, a sine alpha. You have to remember this from your head, by the way. You'd rather forget everything and remember the three types of solutions. This is what you must actually remember. Everything else is common sense. This is what is going to actually carry you. This is the most so you say, okay, what should I remember for this part? Remember the three types of solutions. If you remember the three types of solutions, then well done. You are done. The three types of solutions. The three types of solutions you can get for this homogeneous. It is e to the alpha, and remember alpha is going to be the real number, because complex numbers have two parts. Complex have a real part, then they have an imaginary. For it to be called a complex number, it has two parts. A real number, a normal number, and an imaginary number, which is a number with an I. So the real part you call it, you put it on e to the alpha x. Then you're going to say inside, you say a cos, then you put the imaginary part. Then you say plus b sine, then you put the imaginary part. That is what you do for the situation where you get complex solutions. Let's quickly do this one. So let's solve. Oh, how easy. Let's quickly do it. So here we have our situation. What do we have now? Y prime prime is equal to this, and it is equal to 0. The moment you see it being second order and equal to 0, you see the second derivative, and you see it equal to 0. That means it's this situation which we've been talking about. What did we say? We said you convert to D operator form. So what is D operator form? In D operator form, what you must know is that if we are going to say D prime prime, you must be able to know what it means when we put each of these D's. Okay, usually we put it as like this, to say D, then D squared. Let me put it as D, then I'll say D squared. These are the important ones. These are only, when we say D, this just means D dy. And when we say D squared, it means D squared dy. Okay? So what I'll be now doing is, if we have a derivative with respect to y, we may as well put it like this. Okay? If we put d as the derivative, then if we are going to have the derivative with respect to y, it'll be dy, then d2y, which would be like this. So usually what we are going to do is, I actually had not put the y, but you should put it. Because what we are going to do is we'll put the y outside when we replace the derivative. So let's put it and let's show you what I mean. What you're going to have is, d just means the derivative. So if you now want the derivative with respect to y, you call it dy. If you want the second derivative with respect to y, you say d squared y. So now if you are now creating the auxiliary equation, all you're just going to do is you're going to remove the derivatives and put them in D operator form. Okay? You went up. So you put just now. You put the derivatives and you put it in D. That's the very same thing but in D operator form. So we have the second derivative with respect to y. So it's like you're saying D squared y plus 4 for the derivative with y, it's plus 4 dy, then plus 5y. 5y you don't change, is equal to 0. Then we factor out the y, so it would be d squared plus 4d plus 5, and you factor the y out. This is equal to 0. This is the form which we actually call the D operator form. This is now going to be our D operator form, where we have a y outside. That's our D operator form. So now, from D operator form, you are now just going to ignore this d's and the y, and you create an auxiliary equation. So what you're going to do, you're going to, wherever there's a b, you're now going to put a d, you're now going to put an m. So you're going to say let m squared plus 4m plus 5 be equal to 0. Wherever there was d, we've put an m, we ignore the y. Now you solve this one. Okay, now you solve this one. So how do we solve it? How do we solve it? You know how to solve? Yes. How do we solve it? We are just going to have quadratic formula. We use the quadratic formula all the time when we want to solve. So you're going to say your a is the number before m squared, which is going to be 1. B is always the number before M, and it should be with its sign. So in this case, B is 4. Then we have C. C is the constant on its own. In this case, it's 5. So the first thing you should always get is B squared minus 4AC. Always get that, which is going to be 4 squared minus 4 by 1 by 5. This helps you to know if the solutions are even there. This becomes 16 minus 4 by 1 is 4 times 5, that's 20, which is going to be negative 4. Wow. Let's check it again to make sure we didn't do a problem in copying there. Y prime prime plus 4y prime plus 5 is equal to 0. So d plus 4d plus 5 is equal to 0. Then we have it like this. Because if you get your b squared minus 4ac being negative, that means you have no solutions. So you can't even continue, because this means that our quadratic equation has no solutions. Okay, why does it have no solutions? Because you have your b squared minus 4ac being less than 0. It affects the whole thing. Let me confirm one more thing with you as I'm doing this. I'm double checking something. All right, there we have it. I've put it back. Can you hear me? Can you still hear me? And can you see the screen? Okay, so this is me in the year 2 mindset. This is me in a year 2 mindset for Emath. Sorry for that. I've just been doing Emath with the but here I had almost forgotten. For us, we know that we're going to get complex solutions. So anyway, we have it as a negative 4. Let's go ahead and let's finish it up. So what you'd be now saying is, you now say m is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Sorry for the small glitch, okay? That happens when you teach a lot. So now let's find the m. So we'd say our m is equal to a minus of b. This, for us, you don't say no solutions. That just means we have complex solutions. So it just means we have complex solutions. This is absolutely easy. Now let's go for it. So m will be equal to, what is our b in this case? It's a 4. So it's a minus 4 plus or minus the square root of this b squared minus 4. You see, we found it as negative 4. All over 2a, which is 2 by 1, because our a is 1. But then it will be say m is equal to minus 4 plus or minus the square root of negative 4. We all know what it is. You just say, you'd be saying negative 4. Instead of negative 4, you say it is the square root of 4 by negative 1. And what we'll be now saying is, and it will be by over 2, which is going to be, even if you want to divide, you can still divide, okay? To say 2 into 2, 1 into this negative 4, it becomes negative 2. So you'll have m being equal to negative 2 plus or minus the square root of 4 by I squared. Because we know that I squared is equal to negative 1. So what you'll be now having is minus 2 plus or minus the square root of, this I squared, you can bring it out. Anyway, the square root of 4I squared is the square root of 4 2 of I squared I. So it'll be plus 2I. Which means we actually now will have our m as m is equal to my m1 is minus 2 plus 2I. Then m2 is minus 2 minus 2I. Then minus 2 minus 2I. There we have, anyway, here are our solutions. So now we know how to pick a solution. We trained you, and I told you that's the very, very important part. So what should you do? You should now say y is going to be equal to e to the alpha is the real part. So it's e to the negative 2x. Then in here you now say a cos this beta, this second one, which is also 2. Then you say plus b sine this beta, which is also 2. And you have it like this, right? You put it like this. So now we continue. This is going to be a y, and your job is now to find the a and the b. Anyway, we know what we do. We use the conditions. They'll give us conditions to find these constants. So where are the conditions? Here we have the conditions. We go to the question. Which question was it? Part 3, right? And your questions you have, solve the following. Given that at x0, y0, and dy dx is equal to 2. So let's put that. What do we have? You're going to say, let x be equal to 0, y be equal to 0. We start with that one. So where there is y, we are putting 0. So 0 will be equal to e to the negative 2 by 0. Then you'll be having a cos. You are now putting a cos of 2 plus b sine of 2, which is going to be any number to the power 0 will be a 1. So you just say 0 is going to be 1 multiplying a cos. And we start to put this. All we are trying to do is find solutions. So you have a cos 2 plus b sine 2, which is going to be, now you can say that 0 is equal to a cos 2 plus b sine 2. Where b goes to the other side, you have negative b sine 2 is equal to a cos 2. Then now we have our solutions, but we have these being the same. But they told us at x0, y0, and they also told us dy dx. So we can now say anyway that we have at x equal to 0, then we have x equal to 0. You know that dy dx is equal to, when x is 0, you've been also told what dy dx is. Where are the conditions if we go back? They say dy dx here, y is 0, and they say dy dx is equal to 2. Now, for us to get your dy dx, if we are to get our dy dx and we go to what we had, yeah, here's what we had. We had this y prime prime plus y whatever being equal to 0. Okay? We had y prime prime plus 4y prime plus 5y being equal to 0. So, what would we do here? Let's go to what I have as my y. Here is what I have as my y. Let's differentiate one so that I get the y prime. And I'm going to make it 0. So I'll rewrite to say y is going to be e to the negative 2x a cos 2 plus b sine 2. Then now let's find the dy dx. What is it going to be equal to? Well, it's going to be equal to product rule u and v, because you have exponential multiplying those three. But in actual fact, these trig, if you look at them, you'll be seeing your trig things having no x right now. Okay, so you have your trig things having no x. So you'd be saying, okay, what would you do now here? Let's finish it up. You'd say my dy dx, this is supposed to be product rule. Okay, let me just put here to say, sorry, let me adjust my board. I don't know why there's a glitch. There's a glitch. I don't know why there's a glitch right now. Don't know why you have a glitch in here. Trying to change so that I put the X, because I've been saying that there's an X here. So what you'd be putting is, I don't know. Let's adjust this whole thing. It was wrong from the get-go. So it'll be 2 by 0 plus b sine of 2 by 0. Anyway, you would have it as a cos of 2 by 0 is a cos of 0 plus b sine of 0, which is just going to be a cos of 0 is 1. So 0 is going to be a by 1 plus b sine of 0 is 0. So you can have 0 is equal to a by 1 is a. So you already know that a is 0. Then now we need to find our b. So let's go for it. So this is why we are now doing this one. There is 2x, by the way. I'm sorry. This is b sine 2x. Put that on the solutions. Didn't I put an x? There is an x here. So you'd be now saying, here, dy dx will be now product rule u and v. So what is the product rule? You bring the second one as it is. So it is equal to, you have it. Even if you want to expand, it's still fine if you want to expand to say it is going to be e to the a e to the negative 2x by cos 2x plus b e to the negative 2x by sine 2x. I hope you were hearing me when I was speaking. Sorry, it's glitching because of the network, the Wi-Fi, but you'll be fine. So in here, you'd be now saying, this is still y, by the way. It's not yet dy dx. So now you can now do your dy dx, which you know that this is u and this is product, okay? uv. So a comes as just a constant. Then product rule says when you're multiplying these two things that multiply, bring the second one as it is, cos 2x, multiply by the derivative of the first. When you differentiate this first, for this one you must be good. Differentiation, it comes back as it is, then you multiply by the derivative of the power. If it's for e, it comes back as it is, so it becomes e to the negative 2x times the derivative of the power, so which is times negative 2. Then, so it's like you brought what? The second one as it is, then you multiply it by the derivative of the first. Plus, you bring the first as it is, e to the negative 2x, multiply by derivative of the second. It's negative sine 2x, because you say derivative of cos 2x, you get negative sine. Then you multiply by the derivative of 2x, which is 2. This is product rule stuff, which I can't really have time to explain, but let me explain, or I'll explain it a little bit later, how to differentiate cos and how to differentiate sine. That's some tips that I'll give you, okay? Then for here, we now say plus b. B is just a constant. You do product rule again, which says bring the second one as it is, sine 2x. Multiply by derivative of the first. Derivative of the first, it comes as it is. Then you multiply by the derivative of the power, which is negative 2. Then it now says plus bring the first as it is, e to the negative 2x. Then multiply the derivative of the second, which is the derivative of sine 2x will be, in simple terms, 2 cos 2x. Anyway, this becomes equal to a by, let's simplify. A is outside. In here we have negative 2 e to the negative 2x cos 2x. Then plus, in here there's a negative there, which will also make it negative 2 e to the negative 2x sine 2x. Then it's going to be plus, b is outside now. What do you have? You have negative 2 sine e, negative 2 e to the x sine 2x. Plus, in here you now have 2, a positive 1, e to the 2x, then cos 2x. Which in here you can now put it as simple. You put it outside. So in here you say negative 2a. Then in here you have e to the 2x plus, let's say, negative 2a e to the negative 2x. So here you actually just remain with the cos 2x. Then this negative 2 is gone. E to the 2x is gone. You remain with a plus sine 2x. Then you now say again, if you want to say plus 2 e to the x b, okay, or 2b, since b is a constant, e to the x, it is e to the 2x. E to the negative 2x, it's not anything else. So e to the negative 2x. Then here, what do you now have? In here, you're going to say now, you have cos 2x minus sine 2x. Okay? And this is going to be your dy dx. Now, what you're just going to do is you've been told that these conditions, x0 dy dx is 2. So you're going to say this is your dy dx. Dy dx. So you're going to say let x be equal to 0. So we just substitute. Where there is dy dx here, we put a 2. This is equal to, then now we are now going to substitute. We've found our a already, I think. What did we find? Was it a? Yes, as 0. So this whole thing is going to be 0. So you're going to have plus 2, you have 2b e to the negative 2x multiplying cos 2x minus sine 2x. But you let x be 0, so it'll be e to the so in here you'd be saying plus, here it'll be now multiplying cos 2 by 0 minus sine 2 by 0. 2 is equal to 2 by any number to the power 0 becomes 1. By cos of 2 times 0 is like cos of 0, which is also 1. So now what you'll be having is, and there's a b by the way. Oh, this b will be going. It'll be a b and this b will be going together with it. And it should